Hello class, my name is David Borkowski and this is my project on flight training data center virtualization for the Systems Analysis and Design course. A little background information to pilot flight training. It is a requirement by the Federal Aviation Administration for all commercial pilots. Certification requirements include initial training, which takes about 3 months in the classroom and in different simulators, and then recurrent training in the classroom and simulators every 6 to 12 months for all commercial pilots that are out in the fleet. Training locations, the main one is here in Memphis. There's a small facility up in Anchorage, but the main one is located here in Memphis. The training software we use comes from a company called CAE. They're formerly Canadian Aviation Electronics. And the product we use is called Simfinity. It's simulation software. And some characteristics behind the software is it runs on multiple devices. It actually runs on legacy systems, Windows Server 2003 and Windows Server 2008. And the licensing requirements for we can only use so many instances per airframe per Simfinity software. Code requirements require us to keep it on site, locked up. We can't put it up in the cloud. We can't take it anywhere off site. It has to remain locked up, part of our contractual agreement. And the support for the software is kind of limited because of the legacy systems. The training devices that use the simulation Simfinity software starting at the top are the full flight simulators, which are, as the name says, they're full flight, they're up on hydraulics, they act as if you're flying a real plane. The flight training devices, they're one step down, they just don't have the visuals and they don't have the hydraulics. Flat panel trainers are basically monitors that simulate the same as a cockpit. The classroom, they use the Simfinity software to talk about different applications of the cockpit environment. Briefing rooms, it's a captain and first officer with an instructor in the background using monitors and desktops to simulate being in a cockpit. And the learning center where pilots can train on their own and practice at their own speed and use flight management software in the Simfinity product to train and practice. Looking at the training devices from both ends of the spectrum, the full flight simulators are up on hydraulics. They have 3D simulation. It's like being in a real cockpit. It's as close to flying an aircraft as you can get without actually being in a real aircraft. And a little characteristic behind it, they're very immersive. They support any training. There's very few instances because they're very expensive. They're bound to a single location. And they cost about $2,200 an hour to operate. And then you go to the far end of the other side, the desktop simulation or the vSim. They're less immersive. They only support one type of training on a desktop. We can run many instances though, and they're not bound to a single location. And they're very inexpensive, about $100 an hour to operate. Looking at some virtualization project goals, looking at reduction in costs as far as the amount of physical servers required, the electricity requirements, the cooling requirements for the data center, the physical space required in the data center for the servers, the maintenance of the servers, and the legacy systems that the software runs on, as far as also going outside the firewall for training for pilots. The next step was to look at the feasibility, the technological, can we build it, the familiarity with the application and the technology. Currently, we run virtualization for some of our back-end servers, for some of our SQL servers and databases. So the application and the technology we're already familiar with. The size, we know the scope and the size that would be required. And the compatibility for the legacy type systems and for the data center can all be technologically built. The next analysis was into the economic, is should we build it? The cost, the development, the annual operating, and the annual benefits, which we'll look at a little bit later in the analysis to see if we should build this. The next feasibility study we did in the organizational was if we build it, will they come? The first place we went was for the to find project champions, and these were our two managing directors in flight and flight training. And the senior management quickly bought in as the managing directors pushed for it. Users were very happy to see the potential of what the product can be and that they can use it globally. And the projects align with the business as flight training is our key and our goals that we're trying to accomplish. The project selection classification for the data center virtualization is the size. Ultimately, we want to reduce the size of our data center and reduce the requirements for our data center, which we'll see in a couple slides. The cost should be reduced by reducing the amount of actual physical servers we need. The purpose is to potentially stay on the legacy systems for as long as we can without having to update, to maybe get outside the firewall and provide some Active Directory and LDAP authentication and some security into the Simfinity product. The length for the project should be no more than 6 months once it's scoped out and decided. The risk is pretty small since we're already using virtualization on the back end for some databases and servers. and we're running a client server right now, so we need to continue to maintain that. The scope is roughly the size of what our data center is now, and the economic value should bring a return on investment that is economically feasible. Our current architecture challenges under the client server model is that access outside the firewall is impossible. The vendor has very long update cycles. They don't want to migrate to new operating systems. There's no version checking between the client and server. It's not secure. There's no SSL, cannot use LDAP or Active Directory to authenticate. The broker, there's no expertise or documentation with it. It's end of life at delivery. It only supports the vSIM application. The client is a large client package. It's difficult to install on the client. It's limited operating system support. The server, we're utilizing very low on its resources. It's only set to one simulation type. Updates are time consuming and sometimes very difficult to do. The network, it's very heavy on the bandwidth, bottlenecks at 3 to 7 megabits per second per instance in the network, and the connection issues that come from this bottlenecking have unpredictable results and are hard to figure out where the bottleneckings are occurring. The VDI virtualization architecture advantage for this model is users access outside of our facilities. There's no vSIM client server incompatibilities. Hardware abstraction supports older operating systems on newer hardware. It's secure. We can use Active Directory, LDAP support, and then link clones greatly improve maintainability and reliability. And it doesn't violate our export restrictions on the licensing or the source code for the software. VMware, vSphere, and Horizon View, there's training, support, documentation available. It's actively developed and widely used. Any application can be offered through the VDI environment. The VMware Viewer, it's very small package, easy to install. It supports many different types of operating systems, and we can use 0 clients for the client. Hardware, a physical server could run any type of simulation with more efficient use of the hardware, especially the components like the CPU, the RAM. And then the PC over IP, conservative bandwidth usage, connection, latency issues result in predictable results, and we can maintain a much more robust network and keep our bandwidth usage low. Lab results using Generation 8 hardware showed these type of consolidation rates. Currently, the Airbus 300 and MD-11, for one instance, we need one server, so for 50 instances, we need 50 servers. If you look at the Boeing 777, for one instance, we need 3 servers, which means for 50 instances, we need 150. When we go to the virtualization VDI environment, the Airbus 300 MD-11, we can get 20 instances per server, so for 50 instances, we only need 2.5 servers. The 777, we can get 2 per 1 server, so we only need 25. That's a great reduction in amount of servers we need to run 50 instances each of this Infinity product for each airframe. Here's just a quick training cost comparison for a pilot that's based in Hong Kong, based on an hourly rate of $125 to come to Memphis or to use the VDI environment. Currently about estimated $5,000, 50 hours in flight round trip to come from Hong Kong, and the training time is 8 hours, so it cost about $12,250 to bring the pilot here to train on the Symfinity software. Whereas we use the VDI environment, the pilot can stay in Hong Kong, which means no airfare, no flight, and about an hour to install the software, 8 hours to run it, which would cost about $1,125 using the VDI environment. Here's just a quick comparison overview of the current environment compared to a VDI environment. Obviously in the current it's difficult to deploy vSIM, and VDI would be easy. vSIM cannot be deployed outside of our facilities, and VDI can be. The high maintenance cost per instance in the current environment would be lower in a VDI environment. The architecture can only support vSIM, where VDI we can run any virtualized application. And the cost per instance is roughly $2,500 in the current, where it would be about $500 in VDI. Here's just a quick use case diagram for a pilot that's trying to access some training. If he's inside the firewall, he'll log in, go through VMware View Horizon, he'll log in there, get to the Symfinity application, he can select any airframe that he wants to launch Symfinity training. If he's outside the firewall, he would have to go through 2-factor authentication, then through VMware View Horizon, into the same launching Symfinity, selecting an airframe, and training as he wants. If he wants to request access, it would have to come down through the Active Directory and LDAP settings, and then he would have to identify his business requirement, enter his employee information. He would then be added to the system to access from outside the firewall or inside the firewall, and he can take any type of training on this Infinity environment. Here's a data flow diagram for how an external user would be able to access the environment from outside the firewall. Initially, they'd hit the first firewall on the DMZ, they'd go through the security server, and then they'd hit the next firewall, which would go through Active Directory authentication into the connection server, which would also authenticate into the vCenter server through View Composer, into a link clone, which would give them access into this Infinity environment that would give them a system that they're requesting. To break that down a little bit easier, an external user will come through the internet into an F5 load balancer, big IP, and then be put out to the View connection servers, which are authenticating with the F5s into Active Directory or LDAP, into the VMware vSphere environment. The same direction would go for a local LAN client, except they would not be coming through the internet. They would just go directly into the F5 load balancers. Here's an overview of how the network architecture would look with the switches in the environment for data center virtualization. Right now we're running the F5s in the data center that are connected to the DMZ, to the routers, going to the core switching in a multi-home data center over to another data center. And here's all our switches that are connected throughout in the data centers. Here's the current cabinet architecture. There's 8 cabinets per row with 3 rows. You can see the switches in the middle, one's for redundancy. The same thing with the 4 PDUs. 1 PDU each is for redundancy. It's off building UPS power, while the other one's running off MLGW shore power. We can fit 12 servers per cabinet of a new server style that's 2U. Here's a little layout of how it is with the current systems we have now, with the older 4U servers, with the upcoming 2U servers into the future. Again, there's 3 rows, so that's 96 servers we can get of the new servers that are 2U per row in 3 rows. Implementation of this data center virtualization, the plan would be to first populate row 2, since row is populated with the old client server legacy systems of the 4U servers. We would populate row 2, and we would bring it online and test it on the back end before pushing it out for training. And during the transition, we would slowly phase into the virtualization environment and slowly bring people on board while completely testing the metrics before we shut down the 4U servers and virtualize those. Our forecast for maintenance is we're going to be pushing towards growth and flexibility and pushing towards all the same systems with the same hardware requirements. We can maintain the same products on shelf for many years to come and be able to swap out and hot swap as needed, because we will have the redundancy between the servers and between the vMotion and flexibility. The budget should be reduced since we're reducing the amount of physical servers that are required per instance and that are needed. We're reducing the amount of electricity and cooling that's required for the data center, and we're reducing the amount of servers we need in total. Future issues or problems are minimal, since we are creating an environment that is planned and phased in and properly vetted before pushing it out. And if there's any questions, please don't hesitate to send them to me, and I'll try to answer them as best I can. Thank you.